Or there's one thing I wanted to discuss in this variable and expressions module. So there is something called a apart from like a general standard operators, thematic operators like plus, minus, multiplication, and we often programmers need some more advanced math operations like square root, trigonometric operations, and etc. etc. So instead of square root, calculating a square root, what we can do is either we can implement our own logic, or instead of reinventing the wheel again, what we can do is we can use the built-in library, the built-in Python library. So when I say built-in means like when we install Python, it comes along with it. Okay, so we can have so there is a specific module called math module. We can often interchangeably this thing as a library. So because this code piece of code to perform certain operations like calculating trigonometry, performing trigonometry, calculating a sine, cosine, tangent, and a square root, factorial, and all that, it has already been, the logic to evaluate these things has already been developed, and developed by the Python developer. Okay, so instead of reinventing the wheel, we can import that module, we can import that library and readily use the functions available to us. Okay, so the standard math library module is available in Python, as I said. It has supports theoretic, logarithmic, trigonometric, and etc. functions. So math module, first of all, what we need to do is to import the module using the import keyword statement. Okay, we will be talking about importing modules separately in a different video, but just know that whatever, so math is the name of that module, or math is the name of that library or the Python file. And what we can do is we use the import keyword and write math. We do not need to specify the specific path for this file where it is placed. Python automatically determines that what we are trying to import. So math is the name of that module. When we import it, you may consider it like whatever written in that module, math module, it is being imported directly here. It's just copied and pasted here in this particular file, okay? Now, after importing, you have your own variable num equal 49. And what you're trying to do now here is you're trying to calculate the square root of 49. So a square root is a function. Again, it's a built-in tool. So instead of writing or developing your own tool, developing your own hammer, um, or developing your own machine, this machine of calculating square root is already developed, so we would like to use it. So this square root function, we commonly refer to it as a function. So square root function is a part of the math module. And the way we use that machine, the way we access that machine is first write the name of the module and then enter dot and then type the name of the function, a square root, and then pass the value of which we want to calculate the square root of. Okay, so math is the name of the module that we have imported. Sqrt is the name of the function that we want to use, and then we pass the value. So it should return the square root. So this machine would return the results which we are storing in another variable named num underscore sqrt. Okay, so sqrt is a function defined in math module as I explained it here. An argument is passed to this function, evaluates the square root of the argument and return its value. So so in order to understand functions, so function has a separate set of videos which you can check out later. So in the math module, the commonly used functions in math modules are these, like ceiling, factorial, and round up seal actually round up the value, floor actually rounds down the value. So you can remember this is with the help of let's say, if you have a value, let me pull up the whiteboard. Yeah, so if you have a value, let's say 2.7. Okay, now this 2.7, if you pass this value, let's say this is stored in a variable named x. So now what will happen is if you pass this value in a function ceil, what will it do? It will seal it up, bring it up, round it up to the nearest integer, which is now it will return, it will make it 3. Similarly, if you pass this to floor function, so floor actually bring the value down to floor. Okay, so floor means like it is actually flooring it down, or it's rounding it down the value to the nearest integer. So 2.7 would become 2. Okay, so these are some functions that are available. Similarly, we have the factorial function. So factorial, I guess, is available with the name fact. If you pass the factor value 4, it would return the factorial or the final value of the factorial 4 factorial, which is 4 times 3 times 2 times 1. Okay, so these are some of the operations that you can perform using the math library. In order to determine the complete list of what are the supported functions, you can go to this link and check out what are the available functions. All right, so before we end this video, there is a small activity for you. So determine the final value of z. So in this first example, x equal 2.3, and what we are trying to do here is math.ceil x. So I have just explained it to you. The 2.3 would be rounded up to 2.3 would be rounded up to 3. So z would now contain 3. Okay, let's talk about the second one. So the second one is we're lowering it down to floor, which is 2.3 would be lower down, rounded down to 2. Let's talk about this 4.5. So here we are passing into multiple functions. So nested functions, we will be talking about the functions later. But what we are first doing it, so this is a power function. So the purpose of the power function is, so this is the base. The first parameter, the first input would be base, and the second input would be power. So what it would do is 4.5 would be floor down to 4 first. So 4 would be base and its power of 2. So 4 power 2 would be 16. Okay. Similarly, 15.75 here. So what we are doing is we are actually sealing it up or rounding it up to the nearest integer. So 15.75 would become 16. And if you calculate the square root, it would return the square root of 16, which is 4.0. So because we can calculate the square root of any number which is not a perfect root, so we could calculate the square root of 15.75 and it would return some floating point value. Okay. Similarly, z equals 4. So you can calculate the factorial, which would return the results of factorial of whatever the value that we pass in. All right, so I will see you in the next module. Thank you.